Hello, welcome to the first session on triangles. Herein we'll start taking up the rules on the congruency. The first one being SAS rule of congruency. Let me write it down here. It says SAS rule of congruency. What does the rule say? It says, we read out that part and then we explain with a question maybe. The first one says two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of other triangle. That means we write it down. What that means is not writing down though. We'll be understanding it with the help of few examples. Two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of the other triangle. Let's draw up a figure. I will name that as well. I will give A, B, C and D. We quickly note down this question. It says in the figure OA is equal to OB. It also informs OD is equal to OC. We have to prove or we have to show that triangle AOD is congruent. The symbol is this, congruent to BOC. And also we have, this is first part to be proved. The second part to be proved, it says AD is parallel to BC. To do so, let's take up the two triangles, this AOD and BOC. So we write in triangle AOD and triangle BOC. Let's note down what are the parts which are equal. It's given in triangle, this is equal to this given in the question and this is equal to this in the question. So in triangle AOD, OA is equal to, in triangle BOC it is equal to OB. Similarly, OD of this AOD is equal to this being OC of the triangle. Now what is the third part? These are the given parts, these are the sides. We are applying this angle rule. So if you see, we will be taking up this angle. The rule says included angle of one triangle are equal to the two sides and the included angle of the other triangle. That means this angle is the included angle of the two sides which we have considered. So these two angles have to be proved or said equal. That's quite simple, that angle of AOD is equal to angle BOC because they are vertically opposite angles. So we write, therefore triangle AOD is congruent to triangle BOC, and then bracket we write by SAS congruency. Now the term which we will be using here quite frequently is CPCT, which stands for corresponding part of congruent triangles, because in congruent, when these two triangles suppose have been proved to be congruent, then the corresponding parts will also be equal. What are the corresponding parts? That means angle OAD, this one will be equal to the corresponding part, that is OB, and it will be C. Similarly, there will be few more, like ADO will also be equal to OCB, but we don't need it more for this to be proved. Now OAD is equal to OBC because it is by CPCT. Also, if we observe, those two are alternate angles. If I highlight, kind of make you observe this by, so these two are alternate angles. So if the alternate angles are equal, in that case AD will be parallel. Oh, I'm sorry, this was not supposed to be proved to be equal, we were supposed to prove to be parallel. Now these two are alternate angles, thereby making AD parallel to BC. You can write here, these two form pair of alternate angles for which two segments? For the line segments AD and BC. Therefore AD is parallel to BC. Now we need to we need to know here quite well that as when we are applying two sides and one angle, it has to be SAS. It cannot hold true for ASS or SSE. I'm going to write it down that this is not, ASS is not taken, SAS will also be not considered. Now we may take up another question. To do so, I write it, to make the figure first here. This is named as A and C. This is given to be B. This is D, E, F. Now in this figure, it is given that AB is equal to CF. Then it says EF is equal to BC. Sorry, EF is equal to BD. And third, it says angle AFE is equal to angle CBD. In such figures, we have to quite clearly observe equalities of which two parts of the two triangles given to be equal. It says, after informing about this, it says prove that triangle AFOE is congruent to triangle CBD. We now need to prove them to be congruent. we write in these two triangles AFE and triangle CBD. See, in these two triangles they have given this angle is equal to this angle, so we write it down. AFE is equal to angle AFE will be equal to angle DBC. It's also given EF is equal to BD. These two were already given to us. We need a third side equality. If we observe this carefully, this part BF is actually common in between the sides AF and BC of the two triangles. It is given AB is equal to CF here. In the two triangles it was given AB is equal to CF. Now if we add BF, the common part to both sides, it will be AB plus BF equals to BF plus CF. Right? Now AB plus BF makes it AF. Similarly, BF plus CF makes it CB or BC, because I'm writing it in terms of corresponding parts, corresponding sides. So it is AF is equal to CB. So our third equality I write here is AF equals to CB. So what do we observe now? The sides equal are this with the long, this one, these two. So the angle which included had to be the one which we have marked already. These two angles had to be equal. So now here we write it by SAS criteria. Triangle AFE is congruent to triangle CBD. SAS criteria. It was not at all difficult. I give you a question now to solve or to prove. It is a very easy question. Try to yourself based on SAS. Once it is informed the rule, it becomes very easy to make out the equalities, the parts. Says it's A, this is B, that was C. In this figure they say X and Y are the 2 points on equal sides, A, B and AC. It says, it informs AB is equal to AC in this given figure. And it also says AX is equal to AY. The question asking us to prove that XC is equal to YB. That means these two lines. So which two triangles congruency will derive or drive us to the proof of this? You try to prove the congruency. I'll give you a hint here below. I'd say try to prove the congruency of the triangle which is including these sides, which is XC and YB. So it will be triangle AXC and triangle AYB. Once you can prove the congruency of these two triangles by CPCT, that's the corresponding part of congruent triangles, you can derive XC is equal to YB. I hope you get that. You make out which parts are equal to prove the congruency of these two triangles. Thank you.